there's been a really large increase in science publications on ocean acidification in the last 10 years. So it's increasing rapidly. However, most of those have been on single species, and some of them just on ocean acidification and not including warming. And as we know, ocean warming and acidification are happening at the same time. So recently more and more experiments have been carried out on the combination of ocean acidification, ocean warming, and oxygen loss, and other variable stresses like pollutants. So experiments are becoming far more complicated. Now, analysis of all these data, all these papers show that using meta-analysis methods show that the responses to ocean acidification and warming are quite variable. Some species really have negative impacts from ocean acidification. Others have positive impacts, and some don't react at all. And sometimes it's the juveniles, the larvae that swim around in the ocean that are more vulnerable than, say, the adults. So you can see that it's becoming very complex to understand the whole impact on a single species. But where we really need to get to in the future is how ocean acidification impacts communities of species and whole ecosystems. And these meta-analyses do indicate that organisms that calcify, that produce shells or skeletons out of calcium carbonate, are more vulnerable than others. Coral reef growth is slowing down, and sea butterflies, pteropods, tiny little snails, their shells are actually dissolving now in the Southern Ocean and off the Californian coast in upwellings. So there's an awful lot more we need to do to understand what's happening. But the only real solution to ocean acidification is reduction of CO2 emissions to the atmosphere. So it's a global problem. So this is international collaboration, international negotiation at the policy levels to reduce CO2 emissions. Just over a year ago, it was fantastic that 198 countries agreed to have a goal of reducing global warming to no more than 2 degrees. And in fact, the aim is to bring it down to 1.5 degrees centigrade. And so that was at COP21 in Paris. And then we've had another meeting since then, COP22 in Marrakesh, another UN meeting. And this is where the Paris Agreement was basically implemented. And the first step was to sign up for nationally determined contributions, the NDCs. Now these are contributions to CO2 reduction. And if you take all the CO2 reduction that all these countries are going to do and put them all together, then it is not enough to reduce global warming to under 2 degrees. And it's not enough to reduce acidification to a similar level. So within the Paris Agreement is a 5-year cycle. So they will re-examine the NDCs, these contributions by nations, to see how they're doing. And by then there should be more scientific evidence on what's needed. And then hopefully they'll basically sign up for even greater reductions. So it's a step-by-step process. The only way of making people aware of things is to make sure they hear about it. So that means scientists putting their head above the parapet, being brave, stepping outside their comfort zone and communicating science in an easy way, so that people can understand the implications of ocean acidification, warming, climate change. All of that needs to be communicated using different terminologies, using different words, different languages, to whoever it is you're talking to, which is something that we do in the UK. I think reasonably successfully. We'll go to schools and talk to children, and they get it. If children can understand something, then policymakers can as well. So we will go and talk to policymakers and build trust with them, build rapport, because often the questions that they want answered are different to the scientific questions. So you need this two-way flow of information and knowledge and questions. So their priorities are often very different to the scientific priorities, and therefore can drive the science. And that's what we did in the UK Ocean Acidification Research Programme, is we had funding from our Research Council, but also funding from two departments, government departments, the Department of Environment and also of Climate Change. So all three together funded this programme and really helped drive some of the science questions. One of the sub-parts of Sustainable Development Goal 14 is specifically on ocean acidification, and that's to understand ocean acidification, and to reduce the impacts of ocean acidification, and that's including through international collaboration and development. And that's actually an awful lot is wrapped up in that, because to reduce ocean acidification actually means that we have to reduce CO2 emissions in the atmosphere. So that's back to the Paris Agreement. So you can see both goals are actually very, very similar. The other things that we can do is build our monitoring and observing networks, because at the moment very few countries are monitoring ocean acidification, and if you aren't monitoring it, then you can't measure, which means you can't manage. So from monitoring and observing it to management is hugely important. So one needs to do that for policy making, and there are a lot of countries in the world that aren't observing it. A lot of developing countries don't have the capacity to do that. So one of the aims is to build a global ocean acidification observing network. And for that, those of countries, nations that can have the ability and the knowledge and the training need to actually build capacity around the world. And then when we have, and then we all need to share that data in one big global database so that we know what's coming and when, because this data will help feed the models that enable us to look into the future and plan ahead. Well, Britain is an island nation surrounded by sea, and we also enjoy our fish and chips. So perhaps not as refined as sushi, but we all like to go by the sea for our holidays, even if it's raining. You know, we enjoy the ocean. It touches our hearts, and I think it's the same in Japan. And 10 or 15 years ago, no one in the UK, other than one or two scientists, heard about ocean acidification. But even with lots of interviews like this and press activity, there's about 20% of the UK public have heard about ocean acidification. So that's only 1 in 5 people. but it is better than none. And these things take time. And it's a continuous effort. And I think science has a real job to play here, and scientists have a role to play in communicating how important the ocean is to everyone on Earth, even those in inland nations. The ocean produces oxygen in the atmosphere, the air that we breathe, moves the climate and the weather around our planet, and heat. So it's hugely important, and what it's doing at the moment is it's absorbing over 90% of the heat from global warming. So that's the ocean soaking up all that heat. It's also soaking up over a quarter of the CO2 emissions. So climate change would be even worse if it wasn't for the ocean taking up the heat and the carbon dioxide. And it's receiving all the water. And of course that's causing the sea level to rise. And it will continue these roles, but it will have a cost on nature, on the nature in the ocean. And so it's actually realizing that everything that each and every one of us does has an impact on the planet and the ocean. I think once people are touched, I mean, we're all touched by the ocean, and once they really have a good understanding of what's happening, because the ocean is so important to Japan and Japanese society and Japanese food and culture, then actually seeing what the future impacts will be if we don't change may make a difference to everyone's reactions and to policymakers as well. So communication, communication, communication. Well, I commend your role so far. You know, funding research into ocean acidification is hugely important, and that's a very important first step. I think there are other things that, not just the foundation, but others around the world should think about, and that is continued support of science and investment in science, so that we can really get the evidence there for policymakers so they can make well-informed decisions. I think international collaboration is hugely important, because not one nation can do it all. The other aspect I think you could think about is actually finding a voice for science, because we need to really listen to the ocean and hear what it has to tell us. So communication, I think, is at the heart of good science to policy. I mean, most scientists, me included, spent a lot of my life measuring things, doing experiments, and so on. And it was only when I came across ocean acidification did I, the hair on the back of my neck stood up, because I saw this as something really serious for the ocean that I loved and the life. So I decided to start telling as many people about it as I could. And so I kind of fell into the job as a communicator. And other scientists are doing similar around the world, because they're really, really concerned about ocean acidification and warming and sea level rise, and they're speaking up. And it is helpful to help train these communicators, to give them advice, perhaps some training sessions, and have press teams so that they can help write, for example, press bulletins that will interest the press and not be deadly boring. So it's getting the messages right, but at the same time keeping the integrity of the science perfect as well. Because when you generalize, like you do when you're talking to the media, you can misconstrue facts, possibilities, become facts, and generalizations can warp the scientific knowledge. So it's actually a very, very difficult line to tread, and that's where that's probably why scientists are a little frightened of doing this sort of thing, and that's why they need guidance, and they need to be able to feel that they're within their scientific boundaries on what's okay to say and what isn't okay to say. So they have to feel comfortable that they're not exaggerating or misconstruing evidence. So it's a real challenge. They need help.